All right. Hello, everyone. Welcome to my YouTube channel. Today, we're going to be talking about integration of products, especially by part. This is the third video in this section, okay? So please go back and have a look. Previously, we talked about integrating once by part, integrating twice by part, and I also talked about the general formula on how to determine the U using the isolate method, and also the formula for integration by part is integral of u dv is equal to uv minus integration of v du. So, but there's some kind of questions that you tend to integrate more than twice or severally, or you get into a kind of a loop. A classical example is integrating e(3x) sine x, okay? So based on the previous video, like I've explained, how do you determine the u? You use the isolate. So now we are having exponential and trigonometry. So that means our tree is going to be the u, okay? And exponential, which is the e in the late, is going to be the dv. So the du, so remember I told you for this, I told you that is sine, cosine, minus cosine. So when you differentiate sine, is going to give you sine, it's going to give you cosine. So the du is going to be cos x, and v, when you integrate this, is going to be e(3x) divided by what? 3. Can you see? Okay, so put this in the formula. So when you integrate e(3x) sine x, it's going to give you uv, is going to give you sine x dot v e(3x) divided by 3 minus, we integrate, what is the v? Our v is e(3x) divided by 3, and our du is what? Cos x. Okay? And this is going to give you integrate e(3x) sine x will be equal to we can say sine x e(3x) divided by 3 minus, we'll bring the constant out, which is 1/3. 1/3 integrating e(3x) cos x. All right. Now, the same thing, we still have the same thing. We're integrating now by part the second time. All right. We're not doing it the second time now. All right. So now in this case, for the second time, now our u is going to be, we have exponential and trig. So our u is going to be equal to cos x. Our du, you differentiate cos x, is going to give you minus sine x. So differentiate u, remember, sine gave us cos. So cos will give you what? Minus sine what? X. Now the next one, our dv definitely will be e(3x). So our v is going to be e(3x) divided by what? 3. So we apply it to this again. So when you integrate, go integrating the second time now by part, sine x will be equal to sine e(3x) divided by 3 minus 1/3. So uv, remember this is going to be our u, and this is our what? dv. So our u is going to be cos x, and our v is e(3x) over 3 minus integrating, what is our v? Our v is e(3x) over 3 multiplied by, what is our du? Our du is minus sine x. Are you seeing something here? So if you now continue, so it will now be integrating e(3x) sine x is equal to sine e(3x) divided by 3 minus 1/3 into, we can now say this is going to be cos x Oh, sorry, this is sine x here, and this is sine x here, all right? Cos x, e 3x divided by 3. Now, minus sine x times minus sine x is going to give you plus x. So it's going to give you plus. Then you integrate. You take the 1 over 3 out. So the 1 over 3, right? It will now be e 3x sine x. Now you notice something. We are back to the question again. So if we integrate again, you see, it's similar back to the original question again. So that means if we keep on going, we'll keep on repeating to infinity. Okay, so we can't continue like that. In order to avoid that, all right, what you do then is that we tend to put in an integral function. So we can say let I to be equal to e 3x sine x. Okay, to avoid it. So that means anywhere we see e 3x sine x, we just put I there. Does that make sense? So that means we can rewrite this whole equation now as I. This is I, integral to sine x. Does that make sense? Sine x e 3x. So you have sine x dot e 3x divided by 3 minus 1 over 3 cos e cos x e 3x over 3 plus, now because this is all this is going to be I, so it's going to be 1 over 3 I. This making sense? We open the bracket. So I is going to be sine x dot 3 ex. Sorry, I think I wrote something wrong. So it's the sine x, okay, dot e 3x divided by 3. You open the bracket to be minus cos x e 3x divided by what? 9. Does that make sense? Minus 1 over 3 times this is going to give you 1 over 9i. Does that make sense? So now we have this fraction. I want to multiply both sides by 9, so I'll get this fraction off. So I'll multiply both sides by 9, so it'll be 9i is equal to 3 sine x dot e 3x minus 9 to give you cos x e 3x multiplied by 9 minus what? I. Is this making sense? You take I to the other side, and that will give me, if you take I there, it's going to give you 9i plus I. So it's going to give you 10i is equal to 3 sine x dot e 3x minus cos x e 3x. Now, what is common here? We have e 3x. So we can say 10i is equal to e 3x, exponential 3x, into bracket 3 sine x minus cos what? X. Now we divide both sides by 10 to make absolute of the formula. Then I is going to be equal to e 3x divided by 10 into bracket 3 sine x minus cos x plus c. And that will be the answer for that. Okay? So the only difference here is still the same way. It's just this concept here that I just added, all right? The concept of adding an integral sign, all right? Everything is the same thing. Okay, everything is the same thing. In the same way, you solve it, okay? So you have this. You make the u, the v. We did the first integral by parts. Now we did the second time. When we repeated for this one, we did second integral by part, and it got us back to the same original question, and we can't continue like that. So we then have to use the integral I to be equal to that. And we now make absolute of the formula, and we simplify it, and now we get for that, okay? And that's how you solve exponential for this. All right, so that'll bring me to the end of this video. So the second one I'll be talking about will be going straight to integration of partial fractions, okay? So feel free. I might start with integration by substitution first. I might do the video first before partial fractions, depending which one comes first in my mind. But any of them, I might do partial fractions, then do substitution. But for integration by product, please go back, have a look at all of them. And if you have any question, please let me know, and I'm going to solve more questions for you. All right, so please don't forget to like, subscribe, and you can share to your friends as well. And please do let me know if you have any questions. Thank you very much.